reporter Marian Lada and Qasim Rosida will be explain and discuss about the structure of atom.
Good day everyone! My topic for today is about the structure of the atom. But before I'm going to discuss, I'm gonna show you first the key terms of my topic. And that was the key terms of my topic. So, I proceed now to the discussion and we start to the atomic particles. Atoms consist of three basic particles: protons, electrons, and neutrons. The nucleus, which is in the center of the atom, contains the protons positively charged and the neutrons no charge. The outermost regions of the atom are called electron shells and contain the electrons negatively charged. Atoms have different properties based on the arrangement and number of their basic particles. The hydrogen atom contains only one proton, one electron, and no neutrons. This can be determined using the atomic number and the mass number of the element. So, as we can see to this concept, these elements is the elements such as helium that made of atom. This one. Atoms are made up of protons and neutrons, which is located within the nucleus. This is the protons, this one, and this is the neutrons, which is located in the nucleus. This one. And with the electrons in orbitals surrounded by the electrons. This one, the first, this is the electrons. Next is the atomic mass. Atomic mass, protons and neutrons have approximately the same mass, about 1.67 times 10 to the power of negative 24 grams. Scientists define this amount of mass as 1 atomic mass unit or 1 Dalton. Although similar in mass, protons are positively charged while neutrons have no charge. Therefore, the number of neutrons in an atom contributes significantly to its mass, but not to its charge. Electrons are much smaller in mass than protons, weighing only 9.11 times 10 to the power of negative 28 grams, or about 1 to 800 of an atomic mass unit. Electrons contribute greatly to the atom's charge, as each electron a negative charge equal to the positive charge of a proton. Therefore, they do not contribute much to an element overall atomic mass because when considering atomic mass, it is customary to ignore the mass of any electrons and calculate their atoms based the number of protons and neutrons alone. This table shows us the charge, mass, and the location of the proton, neutron, and electrons. Both protons and neutrons have one atomic mass, which is located at the nucleus. However, protons have a charge of positive 1 and neutrons are uncharged. Electrons have a mass of approximately 0 atomic mass unit, orbit the nucleus, and have a charge of -1. Let us now proceed to the volume of atoms. Accounting for the sizes of protons, neutrons, and electrons, most of the volume greater than 99%, in fact, empty space. And despite all this empty space, solid objects do not just pass through one another. The electrons that surrounded all atoms are negatively charged and cause atoms to repel one another, preventing atoms from occupying the same space. So these intermolecular forces prevent from falling through an object. Example of this is the chair. So that's all for today and thank you.
Hi guys, good afternoon. I am here to talk to you the continuous about the structure of atom. So, ito yung mga parts na binigay sa akin ng aking mga groupmates. So, let's start it. Number 1 is about the atomic number. The atomic number, an element contains an equal number of protons and electrons. So, ang atomic number daw ay it's contain an equal number of proton at saka electron. So, mamaya na ako nagbigay ng example guys wasas ako guys, unya na ako maghatag sa mga example sa akong gibasa. So, let's continue. Next is the mass number. So, the mass number, also called the atomic mass number or nucleon number, is the total number of protons and neutrons in an atomic nucleus.
Thank you so much, my two reporter. Now you have the video to support the discussion about the structure of atom so that we will be understand this topic.
Atoms are the fundamental unit of matter. They're made up of three types of subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Protons and neutrons are located in the nucleus at the center of the atom, while the electrons orbit the nucleus. Let's take a quick look at an atom of carbon. Notice how the 6 protons and 6 neutrons reside inside the nucleus, while the electrons are shown in orbits surrounding the nucleus. The number of protons identifies the element. All carbon has 6 protons, and therefore 6 electrons. However, there may be minor variations in the number of neutrons in atoms of an element. These variations are called isotopes. It's a little difficult to show the exact location of an electron. This is because electrons have almost no mass and orbit the nucleus of the atom at incredible speeds. Therefore, their precise location at any given moment can't be determined. For this reason, electrons are often shown as a negatively charged cloud around the nucleus. However, other diagrams show the electrons as existing in rings or orbitals. Orbitals are often used to illustrate the number of electrons at different energy states surrounding the nucleus. This is important because only the electrons at the highest energy states, or outermost orbital, participate in chemical reactions. These are called valence electrons, and they are involved in the formation of chemical bonds between atoms.
And now we have the second reporter, Ms. Charis Sumangil, about the periodic table.
Hi guys, I will be the next reporter. I am Charissa Migar. So today, I will be discussing about the periodic table. Before we will proceed, what is periodic table? Who was the father of periodic table? And lastly, what are the classifications of periodic table? So, let's start.
The periodic table is the most powerful tool chemists have for organizing chemical information. Without it, chemistry would be a chaotic, confusing jumble of seemingly random observations. What makes the periodic table really invaluable is its use as a predictive tool. You can predict a lot about the chemical behavior of an element if you know where it is on the periodic table. Each element is represented by one square on the periodic table, with a 1 or 2 letter chemical symbol. Many of the chemical symbols are derived from the English name for the element, but some come from other languages. For example, the symbol for silver is Ag, from the Latin word argentum. The symbol for lead is Pb, from the Latin word plumbum. Above the chemical symbol is the atomic number of the element, and below the symbol are the full name of the element and its atomic mass. Most elements are metals, and you can find them on the left and in the middle of the periodic table. Metallic elements are typically shiny and are good conductors of heat and electricity. Nonmetals are found on the upper right of the periodic table. Except for hydrogen there on the left, it's also a nonmetal. Nonmetals generally are not shiny and are not good conductors of heat or electricity. The dividing line between metals and nonmetals on the periodic table is drawn as a thick staircase. The elements that are found on either side of that staircase are often called metalloids, and they have properties that fall between metals and nonmetals. Notice that the atoms are listed in order of increasing atomic number as you read the periodic table from left to right, top to bottom. Each element has a unique atomic number. That's the number of protons in the nucleus of the atom. So, why are the elements organized into rows and columns? Why don't we just put the elements in a long list? It turns out, if you arrange elements by atomic number, a pattern emerges. There is a periodicity, or a repeating, of certain characteristics. For example, every so often, an inert gas appears. Right next to it will be an element that reacts violently with water. This periodic repetition is known as the periodic law. This is the basis for organizing the elements in the periodic table into columns. A vertical column of elements is called a group, or a family. The elements in a group have similar chemical properties. We now know that's because they have similar valence electron configurations. There are 7 horizontal rows in the periodic table. These rows are called periods. Each row corresponds to a different energy level occupied by electrons. The 2 groups on the left are the alkali metals and the alkali earth metals. The s orbitals in the outermost shell of the atom are being filled in these groups. On the right is a block of 6 columns. These elements have the outermost p orbitals being filled. Notice on the far right are the noble gases, which all have a filled valence shell of electrons. In the middle is a block of 10 columns, the transition metals. In these elements, the outermost d orbitals are being filled. The asterisks take you to the bottom of the periodic table, where there are 2 rows of 14 columns. These are the inner transition metals, also known as the lanthanides and actinides. These elements have the outermost f orbitals being filled. The groups in the periodic table have been numbered in a variety of ways over the years. Depending on which periodic table you look at, it may have 1, 2, or even 3 different systems for numbering the groups. You may see the groups labeled with Roman numerals and A's and B's. This system was popular in North America and Europe. Unfortunately, the designations were somewhat arbitrary. In North America, the A groups were the S and P blocks, known as the representative elements, and the B groups were the D block, the transition metals. Meanwhile, in Europe, the A groups were on the left and the B groups were on the right. And in both systems, there was one triple-sized group called Roman numeral 8. To eliminate all this confusion, the International Union of Pure and Applied Chemistry, IUPAC, proposed a system that numbers the groups 1 through 18. Mendeleev came up with the idea of listing the elements in order of increasing atomic mass. Almost simultaneously, Lothar Meyer in Germany published a nearly identical system for classifying elements. We generally give credit for the discovery to Mendeleev because he devoted so much time and effort championing this new system, and he helped it become widely accepted.
There are are the major person contribute the periodic table. One of them, Anthony Laurent Villabosser, Johann Wolfgang Duberiner, John Newlands, Julius Lothar Mayer, and Glenn T. Seward. Thank you so much to all my reporters and to all my classmates. Thank you for watching. Sana may natutunan kayo sa aming topic na ito. At this time, may bibigay ako sa inyo na activity. This activity, you will send me in a messenger, Rosmelia Casimo. Only answer. And this activity, my deadline is May 9. Thank you so much for your cooperation. Keep safe, guys. Thank you.